Now, this is take 2 on this problem because I got interrupted. So, I don't know where I was, but let me tell you where I am. I need a visual of this. So to get a visual of this, I'm going to graph in a coordinate plane, somewhat to scale, the ordered pairs that I know. I know that 0, 1 is a point on this. I know that 2, 2 is a point on this. I also know that the equation g of x equals a half, which is going to look like this, exists in this. So reading this more clearly now, one more thing, 1k, someplace there's a value k for 1. So the function's continuous, and the equation g of x, that's this red line here, must have at least 2 intersections with f. So f is a function that has to go through this, it has to go down here, and it has to go back up to get to 2. We know it has to go down there because there's at least 2 points of intersection. So what could k be? Could k be 0? Could the graph actually come down and hit the y-axis? I don't see why it couldn't. Could it be a half? No, because if it's a half, it's going to come down here and touch this one time and back up. That's not possible. Could k be 1? No, because it's not going to hit it at all. Could it be a 2? No. Could it be a 3? No. So it's going to have to be answer A. This one I've spent a lot of time on. And what I landed on for this one is using the answers, because it's multiple choice, is probably your best bet. So here's what I'm going to do. Let me explain to you the concept first. For what values of k will this have point discontinuity? We know that point discontinuity happens when you can cancel common factors. So that means that x squared as the first term and the plus 6 as the last term has to factor. That could factor in several ways. Could be x minus 1 and an x minus 6. Could factor into an x minus 2 and an x minus 3. Those are the only ways this could factor. So whichever way it factors means the denominator is either going to be an x minus 1 or an x minus 6 or an x minus 2 or an x minus 3. Personally, I think all that information is probably a little much for you. So here's how I'm going to do this. Just going to plug numbers in for k and see which one gives us the correct answer. So I will cut to the chase and tell you this one does, and let me just show you how it gives you the correct answer. If k is 3, it's going to be x squared minus 3 plus 2, x plus 6 over x minus 3. It's going to give us x squared minus 5x plus 6 over x minus 3. Now the numerator should factor so that it has a factor of an x minus 3, and it does. Since the x minus 3's cancel, there's a hole there. So the answer is E. Number 6. Suppose f is continuous on the closed interval from 0 to 4. Just going to draw something real quick. An x and y coordinate plane, an x and y coordinate plane. I'm going to do this twice because I've done the problem before. So it's continuous on the closed interval from 0 to 4. I'm thinking intermediate value of theorem again, since it mentioned closed interval. Suppose f of 0 is 1. So I'm going to put that here. And f of 1 is 2. I'm going to put that here. F of 2 is 0. I'm going to put that here. F of 3 is negative 3. I'm going to put that down here. f of 4 is positive 3. I'm going to put that up here somewhere. Picture's not to scale. Which of the following statements about the zeros of f is always true? Well, let me just copy this over here, because I'm going to show you a couple different things that could happen to this. Since this graph is continuous, it has to hit all these points and still be a function. So in this case, it is hitting the x-axis 2 times. But does that mean it's limited to 2 times? It is not. This graph could come down here and back up, and down here and back up, and down here and back up. We don't know what it does, but we do know that it has to cross the x-axis here in some place over here. So it's at least 2 times. Let's see. Exactly 1? I don't think so. Exactly 2? Well, it's exactly 2 in the first picture, but I showed in the second picture that could be more than that. Has more than 2 zeros? It might. It doesn't have to. The only thing that's certain is that it has more than 1. Number 7. This function has removable discontinuity at no. Those are the only places it could be. And it has neither of those because those are jump discontinuities. So that's E. Same picture. Number 8. On which intervals is it continuous? Well, it's continuous from -3 to -2, which all the answers show that. It's continuous right after -2 to 1. Pardon me, not to 1, to 0. This is 0 here. Continuous means we can trace it without lifting up our pencil. It's continuous here, here, and here. So that middle interval goes from -2 to 0. Does not include -2. But that one does, so that's not right. It does include 0, which the rest of those 3 do. And then it's continuous from 0, right after 0 I should say, to 2.5. So this is wrong because it should be open. This one, the second one, looks like it's possibly going to work. Third one looks like it also works. So I'm not looking at something right here. B doesn't work because it's supposed to not include the 0. So we know it's not B, we know it's not here, we know it's not here. Let's look at C and E a little bit closer. So just reading C, it says it starts at -3 and goes to -2. It includes that. I agree. Then it starts at -2, doesn't include it, and goes to 0 and includes it. I agree. Starts at 0, doesn't include it, and goes to 2.5. So I'm thinking it's going to be C. E says a very similar thing, but E is breaking this into 2 different intervals, saying it's not continuous at 1, which is false. So the answer is definitely C. 9. Where does the function have jump discontinuity? Has it here at -2, has it here at 0. So 2, -2, and 0 is answer D. I will be back hopefully shortly to do the extended response. Short answer, free response, whatever it's called.